Hello, welcome back to my channel. Today we shall be talking about the topic atmospheric physics. But before we continue, we have to understand the meaning of the word atmosphere. The atmosphere is a gaseous envelope that surrounds the planet. As you can see from the figure here, it is subdivided into layers. We have the troposphere, which is the layer closest to the surface of the Earth, followed by the stratosphere, mesosphere, thermosphere, and the exosphere. The atmosphere is a combination of two Greek words, the atmos, meaning gaseous, and sphera, meaning ball or sphere. So when we combine the Greek word, we have the atmosphere, which is the atmosphere, which in English it means gaseous ball or gaseous sphere. The gases are held by gravity not to go beyond a certain height or altitude. The most abundant gas in the earth is nitrogen, and it occupies about 78% by volume, followed by oxygen, which is about 21% by volume. Then the remaining 1% is occupied by other trace gases, where we have the argon, xenon, neon, hydrogen, helium, krypton, carbon dioxide, and all of that. So you see the greenish portion of this shape here is occupied by nitrogen and then followed by oxygen. So the second figure is just the same as the first figure. Okay, so these gases are important in our atmosphere because they act as a massive filter. It keeps away most harmful ultraviolet radiation without allowing them to get to the surface of the Earth. So you see the figure here trying to show us the layers of the atmosphere and how it helps in attenuating some harmful UV rays and radiations and also particles that emanate from the sun. So here it filters them in the atmosphere and allows only the visible portion of light to get to the surface of the Earth, which will re-radiate in the form of infrared. So this other color you are seeing here signifies infrared. Okay. Nitrogen, as I said earlier, occupies about 78% by volume. It is also essential to all living things because it plays a major part of the amino acid, which is the building block of protein and of nucleic acid, such as DNA, which transfers generic information to subsequent generations. Atmospheric physics. Atmospheric physics is the application of physics to the study of the atmosphere. That's how we can define atmospheric physics, the application of physics to the study of the atmosphere. We can also define it in meteorology. We can also define it this way, that it is a branch of meteorology which is related to climatology. So atmospheric physics is a branch of meteorology which is related to climatology. That will quickly take us down to atmospheric variables. When we say variables, it means those values are not constant, but they keep changing. So there are atmospheric variables in our atmosphere. If you don't call them the atmospheric variable, you call them the meteorological parameters. They mean the same thing, atmospheric variables or meteorological parameters. Atmospheric variable is a set of routinely collected measurements. They include temperature, humidity, wind, pressure, and all of that. We are going to discuss them one after the other. Let me take the first one here, temperature. Temperature, we do define it as the degree of hotness or coldness of a body. But in real sense, temperature is a measure of the average kinetic energy of molecules, a measure of the average kinetic energy of molecules. It tells us about the heat content of the atmosphere. Okay, so the thermometer is an instrument that we can use to measure temperature. The thermometer usually have different scales. We have the Fahrenheit scale, the Celsius scale, the Kelvin scale, and even the Rankine scale. But in this figure, you can see F here and then C. So the scale used by this very thermometer was the Fahrenheit scale and then the Celsius scale. Humidity. This is the moisture content of the atmosphere. Appears in the form of rain, snow, hail, etc. We use the hygrometer as an instrument to measure humidity. So you see the figure here for hygrometer. The next variable is wind. Wind is simply the air in motion. So we use the anemometer to measure the wind speed or the wind velocity. And then we use the wind vane to measure wind direction. The next parameter is pressure. What is pressure? Simply the force per unit mass, the force per unit area acting on the surface. The force per unit area acting on the surface. So we use the instrument called the barometer to measure atmospheric pressure. You can use the aneroid barometer. You can use the mercury barometer. And their units are in millimeters of mercury or pascals. And then we have another variable here, the solar radiation. So the solar radiation is simply the electromagnetic radiation which is emitted by the sun. They have a short wavelength. The solar radiation can be measured using the pyranometer. So you can see the figure here representing the pyranometer. Thank you very much. That is how far I can go. If you enjoyed our class today, I just want you to go down to our channel and just click on the subscription button, and if possible, share to your loved ones. Don't benefit alone. Thank you very much.